We are going to talk about Friedel-Crafts acylation. This is also an electrophilic substitution reaction of benzene. In this reaction, an acyl chloride, the acyl group of the acyl chloride. Okay, first let me tell you what acyl chloride is. This is acyl chloride. Okay, so this is an acyl chloride. This part over here is the acyl group, and this is Cl is the chloride. So the acyl group is gonna get attached to the benzene, and basically we are gonna add the acyl group to the benzene ring. So the benzene ring, the reaction, the general equation looks something like this. The benzene ring reacts with the acyl chloride, R C double bond O Cl, and the acyl group gets attached to the benzene ring. This is the acyl group that has attached to the benzene ring, and the chloride turns out to be HCl. Chloride combines with the hydrogen which is removed from the benzene, forming HCl. Okay, so this is the general form of the equation, and the catalyst used in this case again could be AlCl3 or could be AlBr3. Well, since chlorine is used, so we generally use AlCl3, but AlBr3, FeCl3, any of them can be used. And this reaction can occur at RTP as well. Well, no special conditions are as such mentioned in the book, so it's okay to leave out the conditions. Okay, now AlCl3 is the catalyst that is used, and RC double bond OCl is the acyl chloride that we have. This R group again represents an alkyl group attached to the C double bond O. Okay, now let's get started. The mechanism, the detailed mechanism is important and can be asked for 4 to 5 marks. Okay, again, this is an electrophilic substitution reaction. So the first step of the mechanism is going to be the same. First step is generation of electrophile. Generation of electrophile. So now how are we going to generate the electrophile? Let's see. Excuse me. Okay, RC double bond OCl combines with the catalyst again, forming AlCl4 negative, and the R C double bond O positive is the electrophile. This is our electrophile. Excuse me. Okay, this is our electrophile. Okay, now this electrophile is going to attack the benzene ring. The second step of this reaction is the attack, electrophilic attack. Our benzene ring. Oh. Okay, benzene ring. And then our acylium ion. Okay, now again an electrophilic attack will start out from inside of the ring and will end at the positive charge of the electrophile. Be very careful. Be very careful at drawing this curly arrow, because the tail of the curly arrow must begin from inside of the benzene ring and the head must end at the electrophile. Then the next step again is formation of the intermediate, as we have drawn in the previous videos. Okay, again in the intermediate we need to display 2 bonds. One bond represents the electrophile attached, and the other bond represents the hydrogen atom. And then the immediate neighbors of this carbon, the carbon to which this group is attached and the hydrogen is attached, the immediate neighbors. From the immediate neighbors or the immediate neighboring two carbon atoms, draw out a crescent shape. This crescent shape represents the remaining electrons because the two of the electrons were used to form the dative bond. The remaining electrons, which is basically the incomplete ring that is left inside, is shown like this. Okay, it's important to cover all the remaining 5 carbon atoms. Okay, and this ring must be facing towards this carbon. Okay, the face should be open towards this carbon atom, and since a dative bond was formed, so a positive charge will come inside this ring. This is our carbocation intermediate. Okay, now this is our intermediate. The positive charge will cause this carbon hydrogen bond to break. And again, be careful while drawing this curly arrow. This carbon hydrogen bond breaks, and the tail of the arrow must start from this carbon hydrogen bond, and the head must end on the positively charged inside. And after this, the ring inside would be restored. The delocalized pi electron ring would be restored inside, and this bond will break, and the double bond OR, this compound is obtained, plus the hydrogen positive ion. Okay, now this hydrogen atom over here, hydrogen ion actually, will combine. The last step of this reaction will combine with the AlCl4 negative and will remove one of the Cl from the AlCl4 negative, forming HCl, and the AlCl3 would be left. This AlCl3 has been regenerated, so as it was a catalyst, so the catalyst gets regenerated in the end. This is a property of the catalyst. It takes part in the chemical reaction, regenerated. It takes part in a chemical reaction, but at the end of the reaction is chemically unchanged. So thank you so much. This is it with the electrophilic substitution reactions of benzene. So meet you guys in the next video on the next topic. Thank you.